don't have started streaming. Mute it. Thank you, sir. Bye, sir. Thank you for your wonderful lecture. So now, students, it's time for some physics running. Now you have studied. I think that you got bored after studying lots of chemistry. I know that it's a boring subject. So now we'll enter into the most interesting thing, that is physics. All of you know. Maybe sometimes it doesn't give you that much of marks like bio, but it is interesting in studies. Okay, that I believe. Okay, that's why I'm teaching physics also. Okay. So namaskar, adab, sat sri akal, welcome back to the 6th lecture of electrostatics. Yes, we are in the 6th lecture, and till now, last class if I am talking about, we have studied little bit of flux. Okay, we have entered into little bit the results of Gauss law. Now today we are going into the complete depth of Gauss law, how the derivations are going to be happening, how we can derive a lot of things using Gauss law, what are the important properties that I can see from Gauss law. These are some things that we are going to discuss. Okay, I am feeling so cold. Wait 1 second. We should increase the temperature. Okay, fine. So now let's start our lecture, students. Are you excited? Be ready with your pen and paper and let's begin. Okay. So let's start from a point charge. What will be the electric field due to a point charge? We already know, isn't it? We already know due to a point charge at a distance r, what is the electric field that you can write? You can write simply kq divided by r square. That is as simple as that. But let's suppose now I have to derive it using Gauss law. Using Gauss law, what are the things? Firstly, I will tell you what are the things that we have studied there. We have studied there that how we can write flux. How we can write flux? We can write it as where is our pen? Where is our pen? Pen. Sometimes our pen got disappears. Correct. So I can write flux as, we have written E dot ds for non-uniform bodies is equal to net charge that is present inside the Gaussian surface divided by epsilon naught. This is what we have already discussed. Correct. So now let's move further from it. For a point charge, what will be the result? Already you know, I know that you people are now very well aware about this fact that due to a point charge, the electric field that you will be getting is kq divided by r square. Kq divided by r square. Okay. So what I will do now, I will try to calculate using Gauss law. For using Gauss law, what I have to do firstly, I have to take a Gaussian surface. I have to take an imaginary Gaussian surface. This is a charge q, and I have made a spherical Gaussian surface, imaginary Gaussian surface. I have taken a spherical Gaussian surface. Important things are what I am telling you. Rest of the, for board purpose, you can write this much of given thing. This will give you confirm 5 marks. It is guaranteed, because if it is a 5 marks, 7 marks bigger question kind of derivations, you will get confirm full mark. If you are writing this kind of diagram, this kind of given things, now no one can cut your marks. Even if you are not correct at the end, you will get your step marks. So if you are going for board exam, it is more than sufficient to. That's why I am giving this much of theoretical thing, and I am not focusing on this. This is the thing that you can easily read out and check from there. Okay. Now board is completely visible, no? Correct. Now let's see what I will do. What is the flux I can write? I can write as E dot ds integration is equal to net charge present inside the Gaussian surface divided by epsilon naught. This is what we know about Gauss law. And now if I talk about, which yesterday also we have seen solve one kind of question. This is the electric field that is coming, and can say this is the area vector as well. At any point, this is the electric field. Can I say this is the same area vector, area vector, area vector, area vector, area vector, that is perpendicular, and both are in the same direction. That means E dot ds. And what is the angle between them? 0 degree. That means cos 0 will become eventually 1. That means what I can say, integration of this dA vector, ds vector will area vector will give you how much? 4 pi r square is equal to, what is the net charge that is present inside this Gaussian surface? What is the net charge present? Tell me. Simply, it is clearly visible that what is the net charge present inside, students? Q. That means what I will write here? I will write simply Q divided by epsilon naught. Now what I can write for electric field? Electric field will be written as Q divided by epsilon naught, and here multiplication 4 pi into r square. Now my students are very smart. What they will do? They know that what is 1 by 4 pi epsilon naught. This is nothing but k. That means finally the result I can write is kq divided by r square. What I can say? Kq divided by r square. This is what we can do simply, and we already know that this was the result that is going to. I just was trying to give you the feel of Gauss law, how it is the things are derived. Now important derivations we will look from here. Okay. I'm again telling it, if you are focusing on your board preparation, these given things that is written here is very important. Okay, so please don't skip these things. Correct. Now next thing for which we have to calculate, there is a wire is looking for me. Electric field due to infinite wire using a Gauss law. Due to infinite wire, what is the result? If I'll ask you to wire, what is what I can say about Gauss law? If there is a finite wire, you remember we have calculated Gauss law in two directions. One was E perpendicular, one was what? E parallel. Correct? These were the two things that we have calculated. Okay. So now what it will become, if I am talking about that, and what was the theta 1 and theta 2, if you remember that case properly, I will tell you. This was the wire, this point was P. What happened? Why it got changed? I don't know sometimes what happens to this. Let's draw from this page. So here now directly let's come to this case. I guess you remember that result, k lambda by r sine of theta 1 plus sine of theta 2, and second case was for second direction was k lambda by r cos of theta 2 minus cos of theta 1. Now here what you can do, what I am trying to tell you, understand that there is some infinite wire is there, and lambda is given. Lambda is what? Charge distribution, lengthwise charge distribution. Charge per unit length is defined as lambda. Let's define as also lambda is equal to net charge, that is divided by length. Okay, divided by capital length. So let's suppose I have taken a Gaussian surface, that is a cylindrical kind of Gaussian surface I have made. Okay, I am interested in calculating what will be the electric field due to this infinite wire. Okay, now tell me what are the directions of electric field. Can say this is the direction that is drawn here, is the direction for electric field. Please pay your attention carefully here. This is the direction for electric field. Now if I will ask you, tell me the direction of the area vector of this Gaussian surface you have taken. This is the Gaussian surface that you have drawn. Correct? This is the Gaussian surface that you have made. If I will ask you about the area vector, what you can do? This is the area vector that you will say for this surface. Correct? For this surface, upper surface, what you will say? This is the area vector. For this side of surface, this is the area vector. Area vector is always perpendicular to the body. And for downward surface, this is the area vector. Now, if I will ask you about the angles between the electric field and the area vector, what you will say? This theta is equal to 0 degree. Here, theta is equal to 90 degree. Here, theta is equal to again 90 degree. And here, theta is equal to 0 degree. Again, correct? And you remember that flux is what? E dot ds. That means a cos term is also coming due to dot product. And if the angle is theta is equal to 90 degree, what is cos 90? Cos 90, students, it is nothing but 0. That means, can you say there will be no contribution from the top and the bottom, correct? Because no flux is passing through them. That is only contribution, and this will be cos 0 is 1, cos 0 is 1. This is what the outline that we have understood from here. Now let's try to write it here. What I can say, let's move to the next page. This is the diagram portion, and let's derive it on the next page. Correct. What I will do, I have drawn a Gaussian surface also here. This kind of cylindrical Gaussian surface we have derived. Now, how I will write? I will write E dot ds integration plus integration E dot ds. This is let's suppose I am writing for the let's name these surfaces also. This is due to surface 1, this is due to surface 2, this is due to surface 3, this is due to surface 4, plus integration E dot ds plus integration E dot ds, and after that what I will write? It will be net charge present inside divided by epsilon naught. Correct? This is what I can write. Further, what I can do? I can say that E dot ds. E dot ds, one is for, let's suppose this is for surface 1, this is for surface 2, this is for surface 3, and this is for surface 4. This is for surface 4. Now tell me, for surface 3 and surface 4, what were the angles? For dot product, when I am doing, can I say it will become theta is equal to 90, theta is equal to 90, theta is equal to 90. That means, can I say this surface 3 and surface 4 will be nothing but 0. Correct? That means left part is only E dot ds for the this part, this surface, and for this surface only. Correct? Two surfaces are left. Now tell me, can I say this is the curved surface? What you will say about the integration of this curved surface? And I can say, because here it is also theta is equal to 0, angle between area vector, and here also theta is equal to 0, so that means simply they will get add up. So I will write 2 times of E into, what is the curved surface area? I can write 2 pi r into L for the cylinder curved surface area. It is equal to net charge. Net charge present, how you can define? You have written that lambda is equal to charge per unit length. That means, if I have to write charge that is present inside, I will multiply lambda with the length. And what is the length that you are having here? Can you say it is nothing but L? That means net charge present, I can write Q, or at the place of Q, what I will write? Lambda into L divided by epsilon naught. Divided by epsilon naught. Now, if I will solve little bit here, what are the things that can get cancelled out? This lambda, this L will simply get cancelled out. Here what is left? Electric field can be written as lambda divided by, here what is left? 4 pi r. 4 pi multiplied by epsilon naught, and here r. Now, my students know very well that what it will become? It will become electric field is equals to 1 by 4 pi. Wait for a minute. This term will become 0, this term will become 0. What are the things that are left? E dot ds from surface 2, that is theta is equal to 0. There also theta is equal to 0. You multiplied it 2 times. Here it will become 4 pi epsilon naught, and the final result that will become is equals to, this will become k, and here it will become k lambda pi. Where we have made a mistake, it should be 2k lambda pi. Wait. I will check any calculation mistake. This is the next place. Okay, got it. See, we have taken the curved surface area as complete. Okay, so there is no need of multiplying here a factor of 2. What you will do? We have already considered the complete curved surface as a whole, so no need for this to write. Simply what you can do, this E dot ds you can take completely for curved surface. This both are from top and bottom surface, because isn't, if you are taking in 3D 2 pi RL, 2 pi RL is covering the complete curved surface that is getting, and everywhere theta is equal to it will be for this, if theta is equal to what, you can say it will be equal to 0, because at every place, if you are imagining a cylinder you are imagining, and all of those cylinder area vectors are coming readily outwards, and electric field is also readily coming outwards from all those portions. So completely combining all of this, I can write it is equal to 2 pi RL. That means here also it will become 2 pi epsilon naught, and here it will be changed, and then what will be there, correct, here what you can see, here 2 pi epsilon naught is there, multiplied 2 divided by 2, multiplied by 2 and divided by 2, what will be left, you can say it will become 2 lambda divided by, here what it will become, 4 pi epsilon naught, 4 pi epsilon naught is nothing but k, that means you can write here 2k lambda by r will be left in denominator, and that is what the electric field due to a infinite wire. You have to remember this result, this is a very very important result, 2k lambda by r. Is it clear how we have derived? What are the steps, that basic steps in every derivation we are following? We are just simply drawing the Gaussian surface, then we are watching what will be the angle between area vector and the electric field, and then simply just we are writing the what is the net charge present inside, and then we are integrating the surface area, that is the total surface area, and that's it. We are getting all the results by following the simple same method. We are going to do some more derivations. Please try to follow these steps so that it will get settled into your mind, so that you cannot forget it again and again. Okay, this is very simple. Let's move to the next one. Okay. Now whatever the scenario is given, then no problem. You can do all the questions. Now see, what is the next one? Topic is it? Electric field due to infinite hollow conducting wire. Electric field due to hollow infinite conducting wire. This kind of electric infinite wire is there. This is the wire, and it is hollow from inside. Hollow from inside means always, I will tell you about spherical surfaces also, charges are present on the surface. Charges are present on the surface. And the first case, I want to calculate at an inside point where r is less than capital R. I want to check for an inside point. How I will calculate for inside point? What is the first step? Inside point means I want to check firstly at any distance, r, I want to check what will be the electric field that I am getting. What I will do, simply draw the firstly Gaussian surface. Draw the Gaussian surface. I have drawn a cylindrical surface. This is what your Gaussian surface. Correct? This is what your Gaussian surface. Now what you will do? How you will write? You will write E dot ds integration is equal to net charge present inside divided by epsilon naught. Now tell me, student, if all the charges are present at the surface, tell me what is the net charge that is coming inside this Gaussian surface that you have drawn. What is the net charge that is present inside? Can you tell me? Imagine. If I am saying this statement only, that all the charges are present at the surface, can I say there is no charge that is present inside your Gaussian surface? That means, can I say this Qin is nothing but 0? And if it is 0, can I say the net electric field that will be coming inside point will be how much? 0, simply. Because you know there will be charges, but it is very, in last class I have repeated it a lot of times, that it is mandatory for the charge to present inside the Gaussian surface. Outside, how many charge you are putting doesn't matter, it will not contribute in having flux. Correct? That means there will be no electric field. Is it clear? Now check the next case, that is outside point. Outside point will be interesting. See what you can do for outside point. Okay, let's derive for it. Outside point. Anyways, if you are smart enough, this is your outside point, and again I have drawn a Gaussian surface, cylindrical surface that is covering the whole part. And this is what your Gaussian surface. For an outside point, can you say it is behaving like again an infinite wire? Because why I am saying that it is behaving like an infinite wire? Because all the charges are coming inside. correct? And it is giving an infinite length. I mean simply I can say that for outside point already I know the result, that is equal to 2 k lambda by r. But still, if you want, again let's derive it. Okay, there's no issue. We'll derive it again. See how we'll do. Again we'll write the equation E dot ds integration plus E dot ds integration plus E dot ds integration. This is I have written for the complete curved surface. This is the complete rounded curved surface. This is for top. This is for bottom. Now students, now you answer me. Now you can derive this very easily. For top and bottom, what is the electric field and the angle that is present between the electric field and the angle area vector? This is present equals to 90 degree, and here theta is equal to also 90 degree. That means what you will say for E dot ds for both these cases? Can I say simply it will be 0? Because already we have seen in the last case that was it, again it was equals to 0, and I can easily say this is the same condition. Last case it was not given hollow, this time it is given hollow. But doesn't matter, you are standing here and you are watching from here. For you it is not anything like it is hollow or it is completely fit. You are outside, that means it depends on the perspective from you, where you are watching it. Now next thing what you will say, it is equal to net charge present inside divided by epsilon naught. The net charge present inside divided by epsilon naught. Now E dot ds, what you will write? The surface area, total surface area, curved surface area for cylinder. I have told you already, it is equal to 2 pi rl. Net charge present inside is lambda L divided by epsilon naught. That means what is the net electric field you will say? Net electric field you can say lambda, and L will get cancelled. Here will be what? 2 pi epsilon naught r. And I know this final result is nothing but 2k lambda by r. This is the net electric field that will be coming from outside point. Is it clear? Same case for infinite wire also. Now if I will talk about the curve, how I will draw the curve, you can see very easily here. This is the representative. All these curves are very important. If you are drawing these curves, you will get extra marks for sure for this kind of curves. What you can say, this is electric field on y-axis. Here is the electric field on the y-axis, and it is varying with some distance r. Firstly, we have calculated for inside point. For inside point of hollow, it is net electric field is 0. You can see the value of electric field here is tending to 0. Just after it is coming at the surface, what will be the value? 2k lambda by r. Just at the surface, what is the value? 2k lambda by r, and here you can see r is equal to capital R. And then how it is varying? It is varying. Electric field is varying. It is inversely proportional to r. Electric field is inversely proportional to r. That means it is a kind of rectangular hyperbola. That means now it will be going and bending like this. It will be follow a rectangular hyperbola. This will be the graph. I hope that now it is very much easier to understand this curve. Okay. Now see. Next one. Okay. First I read the name. Now electric field due to infinite solid non-conducting wire. For non-conducting wire, what you can say? Non-conducting wire means all the charges are present on the surface. That means it is not on the surface, it is completely distributed in the surface. That means it is, this time I will not say that all the charges are present only on the surface. This time I will say that charges are completely present in the surface everywhere. Charges are present everywhere. Okay. So now this time it will become more interesting. How? And what we will define? This time we will define a charge distribution, volume charge distribution, that I will define as rho, and rho is defined as Q divided by volume. Q divided by volume. And what is the volume of a cylinder? That is will be important. Tell me. In the basic classes you have studied about it. What is the volume of cylinder? Pi r square into L. Okay. So now how we are going to do the derivation? Firstly, what we will do at an inside point. The first case we are calculating again for a inside point. Inside point. For inside point, how we will be deriving? Firstly, what I will do? I will draw a Gaussian surface. I will draw a Gaussian surface. Firstly, I will draw a Gaussian surface, and then what I will do? I will check what is the area vector, angle between area vector and the electric field. Draw the area vector and the electric field. This is the electric field and this is same as for area vector. What I can say for here what I will say that angle theta is equal to 90 degree, and for here what I will say theta is equal to again 0 degree. Here also theta is equal to 0 degree, and bottom also theta is equal to 90 degree. That is contribution for this top and bottom will be again equals to 0. What I will write simply again E dot ds plus E dot ds plus E dot ds integration. This is, let's suppose, for top, this is for bottom, and the final one is for the curved area, correct? And then what I will write? I will write the net charge present inside divided by epsilon naught. Now this is the interesting part. How you will write the net charge present inside, correct? How you will write? If volume charge distribution is defined as rho, how you will write net charge? Q net, I will write rho into volume. Rho into volume. What is the volume of this cylinder that you have taken? What is the volume you can write? You can write at what is the volume? We are taking pi r square into L. Okay, let's suppose the length I have taken as L and the radius that I have taken for this cylinder is r. Pi r square into L. Now let's solve it. For the top, flux will be 0 because the angles are 90. Bottom also 0. For curved surface, what will write? Electric field integration of ds will give you how much? 2 pi r into L is equal to rho into pi r square L divided by epsilon naught. Now this pi will get cancelled, r square will get cancelled, L will get cancelled. That means what I can write for electric field, it will be rho r divided by 2 epsilon naught. Rho r divided by 2 epsilon naught. And what is the final? I can say, if I were talking about the variation between electric field and the r vector, I can say electric field is directly proportional to r vector. Correct? Then if I will ask you about the curve, let's discuss about the curve also. It will be, I can say, directly proportional to r. Okay. Fine. Let's move to the next one. Now this time we have calculated for inside. Now can you calculate for outside also? Calculate for outside point. I will say again, because now again I am watching from outside. When you are watching from outside and you are drawing a Gaussian surface outside, can you say what is the net charge coming inside? Again capital Q. Can you say the first case of infinite wire, second case for hollow wire when you are watching from outside, and for this also when charge is distributed in the complete volume, for all these cases can you say it result will be same? Isn't it true? Because from outside it doesn't matter what kind of body you are having, because I only care for what is the net charge present inside your Gaussian surface, and that will be same exactly, that will be equals to Q, correct? Whatever the charge coming, it will be equals to Q. So can you say the result will be again same? Electric field will be K lambda by R. But now let's suppose, sorry, 2K lambda by R, that was the result, 2K lambda by R, I'm sorry. But let's suppose I want to calculate the same result in terms of rho and R, how I will get. Let's see. Firstly, I have to derive a relation between lambda and rho. How I can write? What is lambda? Lambda is charge per unit length, and what is rho? Rho is charge per unit volume. Let's take a ratio for lambda and rho. Lambda by rho can be written as this charge will get cancelled. Volume can be written also as area into length divided by length will get cancelled. That means what I can write for rho can be written as lambda can be written as rho into area. Rho into area can be written as a result. So we'll substitute that. I will write 2 divided by K, I will write 4 pi epsilon naught into lambda. At the place of lambda I can write rho into area, that is pi r square divided by r, sorry, capital R square, that is whatever the radius that is for the wire. Now what I will do, let's check what anything if it is cancelled. Pi can get cancelled, this 2 will get cancelled. What is the value that is left? Rho r square, capital R square divided by 2 epsilon naught into R. This is the result that will be remaining. Now if I'll ask you the variation of electric field with R, you can say electric field is inversely proportional to small r. Electric field is inversely proportional to smaller. This is the result that I can say from here. Okay. You can see finally, because now we have already discussed about the variation, simply you can say for inside point this complete range is for inside point, and for inside point what was the variation? Rho was directly proportional to r, and for this is the variation for outside point. This is the variation for outside point, and outside point it is already shown that it is inversely proportional to r, and here it is directly proportional to r. These are the results that you can say. Now, due to an infinite sheet, what will be happening? This is an also very important result that I will tell you. Finally, you have to remember the result. All the given things are given here. Properly it is given, so you can take reference from there. I am telling you how you will find this electric field due to an infinite sheet. Infinite sheet, it is a normal, you can say this is a sheet and it can behave like an infinite sheet. Okay. Why? Because infinite is not a defined thing. It is just about a reference. Okay. If this is an infinite thing, it is for us. It is not an infinite sheet. But let's suppose I have taken a very tiny particle near it. Can I say for that tiny particle very close to it, I can say this will be behaving like an infinite sheet. Correct? Imagine it. Imagine it. Okay. Physics is all about imagination. Correct? So what I can do here. Firstly, what is that thing that we do always? We will draw a Gaussian surface. Okay. So this is the Gaussian surface that I have drawn, passing through the cross section area of this sheet. This is the Gaussian surface. First step is done. Now second step is what? Tell me. Now you tell me. Lots of derivations we have did. You tell me what is the second step. Second step is what? We will be finding the angle between the area vector and the electric field. This is the area vector. This is the electric field. What is angle between them? Theta is equal to 0 degree. Here what is the area vector? You can write theta is equal to 90 degree. Here what is the area? You will say again here it is equal to 0 degree. Correct? Now I will do what? I will write integration. How I will write? And here how the charges are distributed, because it is an area, that means what kind of area charge distribution will be there, and how it is represented? Sigma. Sigma is written as charge per unit area. This is the way to define charge distribution in area. Now this is already written. Integration of E dot D, integration of E dot D, integration of E dot D is equal to net charge present inside epsilon naught. This is for curved surface, this is for left side, this is for right side. For curved surface, tell me what you will write. The area. This time this is the curved surface area vector, and this is the electric field vector. And for other side also, this is the area vector and this is the electric field. Can you say both sides theta is equal to 90? Theta is equal to 90. That means due to the curved surface that flux will be coming, that will be equals to 0. Now let's understand for these two. What I can say, what is the area of this cross section? Simply it will be pi r square, and here also it will be pi r square. Correct? That means can I say simply they are going to be add up and they will be making 2 into electric field, and the integration of area will give you how much area? Integration will give you pi r square. Now how you will write Q in? What is the net charge present inside? See, I have told you now how is the charge distribution. Q in you will write sigma into area. Now what is sigma? Sigma into total charge that will be coming inside. What will be the area of this cross section that you have used? It will be equal to pi r square divided by epsilon naught. Now what I can do? Pi r square will be simply get cancelled out, and electric field will be coming equal to sigma divided by 2 epsilon naught. Now this is a very important result that you have to always remember. And one important thing, if I will tell you about this formula, is what you can notice. It is not depending on the distance. At what distance you are calculating from the infinite sheet. It is always constant, and how much it is? It is equal to sigma divided by 2 epsilon naught, and the direction is away from the surface. Okay. So this is a very important result. Very important thing to notice here is it is electric field is equal to sigma divided by epsilon naught. It is not dependent on r. Okay. This is what you have to always remember. This is an important thing. Rest of the given things are written here properly. Just cut, copy, paste in your board exam. You will be getting very good marks. Now see, some more derivations are there that I want to tell you. So let's start, and those are very easy. I'm telling you, just understand. First, I will do for, let's start from hollow sphere. Hollow sphere. Hollow sphere can also be given as conducting sphere. Conducting sphere, hollow sphere, or also they can give you this name as spherical shell. Any of these three things are given, that means they are giving you the same thing. It is nothing changed. What is the they are trying to give you? They are trying to give you a spherical body of, let's suppose, charge present is q and radius is r. Charge present is q and radius is r. And now what you have to do? You have to calculate electric field at different point. But how the charge is distributed? When I am talking about hollow sphere, shell or conducting sphere, charges are present only on the surface. That is what you have to understand. Conducting body, that means the charges are present on the surface like this. That means from inside one there is no charge. And due to that, what will happen? First case, we are going to write for inside point. Case 1, I am going to take a small r, that is what going to judge, and this is less than capital R. What is this interpreting? This is meaning that it is a inside point. For inside point, what will be the electric field? Let's start. Let's suppose this is the center. I want to find a electric field at point P. Distance is r, that is smaller than the capital R. What I will do? Firstly, I will draw a Gaussian surface. I have drawn a Gaussian surface, and then what I will write the equation? I will write integration of E dot ds is equal to net charge present inside divided by epsilon naught. Correct? Now tell me, what is the net charge present inside your Gaussian surface? Tell me, what is the net charge present inside your Gaussian surface? Can you say it is nothing but 0? Because all the charges are present at the surface only. Now for inside one there is no charge present. Correct? Now that means what is the Q in, you will say? That means Q in will be 0. That means what I can say about the net electric field inside for an inside one? It is nothing but equals to 0. Is it clear? Is it clear? You understand now this much of Hindi? I hope that this much of Hindi you will understand. So E net will be equals to 0. Correct now? But the second case, for outside point, that is interesting. R greater than capital R. R greater than capital R, that is for outside point. For outside point, what will be happening? That will be interesting. Let's firstly draw the. You will draw a separate diagram for that. Let's for outside point draw it. I want again electric field at some point P at a distance r, and let's draw the Gaussian surface. This is the second Gaussian surface that I am drawing. Again, I will write the same equation. What I will write? Integration of E dot ds is equals to what I will write? Net charge present inside divided by epsilon naught. Now in electric field, integration of ds is going to give you how much? Let's now write it. What is the net charge present? Firstly write that. This is the Gaussian surface. This bigger sphere is the Gaussian surface. Tell me, what is the net charge coming inside? Can you say it? This complete Q charge that was on the surface is the net charge that is coming inside the outer Gaussian surface. That is what you will say. Q in will be written as simply capital Q divided by epsilon naught. And what is the integration of ds is going to give you? Ds integration is going to give you 4 pi r square. Correct? Sorry, I should write about this Gaussian surface. That means it will be smaller because you are writing integrating the Gaussian surface. It will be equal to Q divided by epsilon naught. Now if you want to write electric field, this 4 pi epsilon naught will make it K, and the result that you will be writing is KQ divided by R square. KQ divided by R square. This is the final result that you will be writing. Correct? KQ divided by R square. Okay. And if I will ask you the variation, I will write electric field is inversely proportional to R square. Electric field is inversely proportional to R square. This is for hollow. Same way you can go for solid also. Now next, let's move to solid. what you will do, same kind of derivations will be there also. Now you are, I must pretty much experienced to understand this thing, because from a lot of time we are just applying Gauss law same way. Now what kind of bodies they can give you? Either they will give you solid, sphere, either they can give you non-conducting sphere. Both of these are meaning same. Both of these are same. What I can do, firstly, what kind of body is there? This time again, this kind of body is there, but this time charges are present on the complete body, not only on the surface, inside also charges are present. Net charge is q and radius is capital R. Okay. Again I am going to derive for two parts. Firstly r, small r, that is less than capital R. That means what kind of point I want to calculate for inside point. For inside point, what will be the electric field? Let's understand. What is the first step we always follow? We will firstly take a point P where I want to calculate electric field. Let's the distance is r. Draw a Gaussian surface, spherical Gaussian surface I have drawn. Okay, spherical Gaussian surface I have drawn. And what is the equation I will write? I will write integration of, tell me students, E dot ds, correct? It is equal to net charge present inside divided by epsilon naught. Net charge present inside divided by epsilon naught. Now tell me this time how you will write electric field will be as it is ds vector. How you will write net charge present? This time is it 0? Is it looking 0? No. But is it q? No. That is also not the case. This time it is interesting actually if I will tell you. Because you can say the net charge present inside is will be less than q, but it is not equals to 0. So how we will calculate? I will say what? You remember that scenario? 5 students, 10 chocolates. That is 1 student how much chocolate? 2 chocolates. If I'll ask you for 3 students how much chocolate? 6 chocolate. This is the same way I am going to write the net charge present inside. Very interesting. See, if I'll ask you for complete volume, what is the complete volume? 4 by 3 pi capital R cube. This is the complete volume. How much charge it is getting? Capital Q. For this complete volume, it is capital Q. For 1 unit volume, how much charge is present? Q divided by 4 by 3 pi capital R cube. So now if I'll ask you for this small body, that you have taken, you will write what? 4 by 3 pi small r cube, and will correct how much of charge? You will write q divided by 4 by 3 capital R cube into 4 by 3 pi small r cube. 4 by 3 will get cancelled out, left what will be remaining? We will substitute here. What is the net charge coming inside? This is q in, you will write q into capital R cube divided by, small r cube divided by capital R cube here, and here it is already divided by epsilon naught, correct? Now integration of ds will give you how much? 4 pi r square. 4 pi r square is the total surface area, and take it here. You write 4 pi into epsilon naught, it will make it k, and here it was coming how much? R square. That means k, small r cube divided by capital R cube is remaining, and here it was coming a factor of r square, because here it was what? It was nothing but 4 pi small r square. Now take it here. This will get cancelled out. What is the net thing? Here is the multiplication of q also. That means the final result for inside point. What you will write? It is nothing but k q r divided by r cube. If I'll ask you the variation with a distance, what you will write? Electric field is directly proportional to r. That means what kind of curve you will get for inside point? If I will draw a curve of electric field versus r, you will get a y is equal to mx, till where r is equal to capital R, because it is directly proportional to r. This is the complete derivation for inside point. It is not difficult. It's important. What is the important part? How you are writing the net charge inside present, that is actually important. Okay. Now let's see the other case also. Other case is even further easier. Let's understand here. What you will do? Now this time you want to derive it for outside point. This was your sphere, capital charge, radius r, and you want to derive it for outside point. Let's suppose some point P. From this center, this distance is r. Firstly, draw a Gaussian surface. You have drawn a Gaussian surface, then what you write? You will write E dot ds is equal to net charge present inside divided by epsilon. Now I don't know how many times I have written the same equation. Till now it have to be clear for you. Now electric field into what is ds vector, you will say ds vector 4 pi r square. What is the net charge present inside? Because it is the outer surface, that means it doesn't depend, it is hollow, solid, because you are watching from outside, it will be in the complete charge that is present. Complete charge is how much? Capital Q, simply, as simple as that, divided by epsilon naught. This will be coming here, it will become 4 pi epsilon naught into r square. That means final result will be again same that is the previous case, kq divided by r square. If I will ask you the variation with radius, it will be electric field is inversely proportional to r square. This will be the variation that is present there. So now if I'll ask you about the total curve variation, how for solid body it is varying. Correct. For till inside point it was, what happened? For inside point, you have seen E is directly proportional to R. For outside point, E is inversely proportional to R square. That means directly proportional is a straight line, y is equal to mx. For outside point, the moment it will become here, it will be equal to kq divided by capital R square, and then it will be inversely proportional to R square. That means it will start continuously decreasing. This will be the final curve that you can draw for solid. And for hollow, what it will be there? Outside will be same. Outside will be same. But inside will be zero, because inside there is no charge present, that means there is no electric field as well. Is it clear to you? I hope that you have liked, loved, and you have understood everything, because we have gone in complete depth. I don't know how many applications I have shown you for Gauss law. Till now it have to be clear, but of course you have to do the practice by yourself. So until next time, keep learning, keep growing with tapasya, endigu, and then digu, nama tapasya.